Um, good afternoon, my YouTube viewers. It's Crystal here. I'm just making this code review because what I have done is for the past week or so, or really for the past month, I've been eating, sleeping, breathing, time series analysis and time series forecasting. And yesterday I did a video on SARIMAX, but I didn't put it on YouTube because I put it on a course that I've created. And one thing that I noticed about this video on SARIMAX was the fact that when you did the grid search was on this special metric called AIC, and it wasn't on the metric called the error called rmse. And because of that, I was a bit curious and I wanted to know. I thought to myself, well, what's best? Is it best to do the grid search on AIC, or is it best to do the grid search on rmse? Because if you do the grid search on AIC, then your rmse is going to be high. And so whenever you enter competitions, what you're going to be looking for is going to be the least error. So I decided to conduct an experiment and did two grid searches, one grid search for AIC and another grid search on rmse, and I wanted to see what the outcome of these two grid searches would be, because AIC is a different metric than rmse. So that's what this code review is about. This code review is about the experiment that I conducted. And so what I used was a car sales data set, and I used the SARIMAX model, which is like a seasonal ARIMA. And ARIMA has components of autoregression, moving average, and integration. And the S in SARIMAX is the seasonal. So whenever I started this program, the first thing that I wanted to do is I wanted to make sure that the most up-to-date libraries were installed in Google Colab, because one of the problems with Google Colab is the fact that the most current versions of libraries are not generally installed on Google Colab, and if they do an upgrade on the library, since Google Colab doesn't keep the most current versions on their platform, you're not going to get that upgrade. So if you want to have the most current up-to-date methodology of a library, then you need to install the most current up-to-date libraries, which is what I've done. So that's what I did here. And then after I installed the most current up-to-date libraries, I wanted to import them. And so we imported Pandas SPD, which is a database or a data frame creator, and also it's used for data processing and time management. I imported NumPy as NP, which is for numerical computations, linear algebra, and it creates NumPy arrays. I imported statsmodels.api SSM. And stats models is the time series analysis, time series forecasting library, and it also has statistics in it. I imported matplotlib pyplot, which is a graphics library which plots the data points onto a graph. I imported Seaborn as SNS, which is also a graphics library, but it's more sophisticated than matplotlib because it provides statistics in addition to the graphics, but it's made on top of matplotlib. I imported warning, so we're not getting warning messages all the time. So after I imported the libraries, what I did was I read the CSV file in, and this is a car sales CSV file that I picked up off the internet. It was on a GitHub repository, so I took it. So series equals pd.readcsv, and then there's the website to the library. Index call equals 0, and parse dates equals 0. So what that means is the index is going to be the first column, because in Python the first number starts with 0, and they're going to timestamp it. The index is going to be timestamped as well. I'm going to plot the series so you can see how the series is plotted. You can see that this particular data set has trend and seasonality in it. So we do a histogram so you can see the histogram of this car sales data set. So now what we've done is I've made it to where, since all of the values in the car sales data set were positive, I made it to where you can see both sides of the x-axis. So that just looks pretty neat, but you know, a two-side view. I put in a little bit of statistics. So max S was 26099, and it was on month number 100. And min sales was 5568, and it was on month number 32. I did a little bit of smoothing, and so since we are doing it on a year, I said the window was 12, so once a month, and this is smoothing. So you can see definitely there's a trend here, and since the trend is almost linear, we would say that it's an arithmetic trend. I split the data frame into train and test sets. The test length is 90% of the series. Train is series 0 to train length. Test is series train length to the end. And then we check the shape of the train and test set. So train is 97 rows by 1 column, and test is 11 rows by 1 column. I checked for stationarity by performing the Dickey-Fuller test, and the p-value is 0.66, so that means that the time series isn't stationary, but we could tell that it wasn't stationary by just doing a visual observation on it, because we could see that it had a trend and we could see that it had seasons. But the thing is we're not going to do anything about this, because with the SARIMAX and the ARIMA, they do differencing within the model, and since they do differencing within the model, I'm not going to do any differencing outside of the model. The only time that you would need to do differencing outside of the model is if the model itself didn't do differencing. But we've got ARIMA and SARIMAX, and those type of methods, they do differencing in the model. So you don't have to do differencing. And then you've got the Holt-Winters. Holt-Winters does, it's called exponential smoothing. So you don't have to do anything for Holt-Winters either. So what you need to do is you need to find out the model you use. You need to find out if you need to do differencing. So if you need to do differencing, then certainly do it. But if you don't need to do differencing, then I wouldn't do it, because what you're going to do is you're just going to contribute noise to the system. So something like AR, like auto regression, you might need to do differencing from auto regression, because that doesn't do any differencing within the model. So you need to research the model that you use to see if it needs to have differencing done on it before you actually do it. And then so what we're going to do is we're going to check the mean and the variance of the series, and checking the mean and variance is another way to tell if the data set is non-stationary. So the difference between the train and the test mean is -4,552, so that's quite a bit. And on the variance, the difference between the train and the test was 5.15 to the +6 power. So again, since you have a large deviation between the mean and the variance in the train and the test set, that's telling you that this data set isn't stationary, but we already figured that out just by doing a visualization of it, because we could see the trend was going up, and we could see all the surges were giving it a seasonality. So now we're going to analyze the test set, so you can see an analysis of the test set. So we're going to do seasonal decompose. So we're going to do an additive decompose. So You can look at the series as it is. You can look at the season, so you can see, you can look at the trend, so you can see that the trend is going up. You can look at the season, you can see the surges or the fluxes in the seasons, and you can see the residual, which is a type of noise, I believe. And then we're going to split the data frame again, because we probably don't have to split the data frame again. What I had previously done was so we probably don't need to do that. We probably don't need that. What I had previously done was I had the Holt Winters model in here, and I took the Holt Winters model out. So probably, see, there's your undo delete cell. So I'm going to delete that and hope for the best, because I had the Holt Winters in there, so that's why I had to split the data frame twice. So we'll just hope for the best. Okay, and so we come up to the SARIMAX. This is the code for the SARIMAX when it's testing for the AIC. So the AIC is a metric that's used to see how well the data is fit and trained and fit into the model. And so the lower the AIC, better. It does take a really long time to go through this grid search, because I set through both grid searches, and it takes a really long time to go through the grid search. And so that's why whenever I got the hyperparameters that I needed, that I put little hash marks in front of it so I wouldn't get stuck in the middle of the grid search. But you can see this is the code where it checks to see the AIC, and then you want to have the lowest AIC you can get. And then what it does is, whenever it finds the lowest AIC, what it does is it gives you that information, and then you put the hyperparameters into the model where you train and fit the model, which is what I've done. And so the hyperparameters for the lowest AIC I could find was 211 and seasonal order 01212. And I had an AIC of 3665, because one of the problems that you have here is you had to have enforced stationarity, which was false. You had to have that there, and enforced invertibility, which is false. And so that gave me an AIC of 12, which was really low. But whenever I put the parameters into the model, I had to do enforced stationarity as a true, because if I didn't do enforced stationarity as a true, it gave me really low values that I didn't want. So that is a problem. Now, I suppose hypothetically, I could go through and say enforced stationarity is a true on the grid search, but I think that there were probably problems in that regard. But what I might do is I might go through and do it again with the enforced stationarity and see what happens. And then I had a 3665 with the lowest AIC whenever I put enforced stationarity equals true. So I made my predictions, so you can see that the predictions were larger than the test set. Although it was close, it was still larger. And so we had an rmse of 4189. And then so we went through when we put our predictions and our actual values on a data set, so you can compare the predictions against the actual values. So now what we did was we did the SARIMAX, and it's based on the rmse. So instead of checking to see if the AIC was the lowest, we checked to see if the rmse was lowest. And when we checked to see if the rmse was lowest, the parameters that we were given were 001 for PDQ and 20012 for seasonal order. And whenever I put this on the predictions, you could see that the predictions were a lot closer in scale than the previous model. And in addition to that, our RMSE was 2421 compared to an RMSE of 4189. So the RMSE was a lot lower. So really, in theory, I think that what I would do is, if I was looking to get the best parameters, I would go for the RMSE. I would be looking for the error and not the AIC. But just to make sure, just to be on the safe side, I'm going to go change the parameters, and I'm going to say enforce stationary equals true on the grid search, and see what happens. See what happens. See if the enforce stationarity equals true on the grid search affects the AIC. I think that it does. Well, I know that it does affect the AIC, but I would like to see how it affects it. And then, whenever I have done that, I will carry out my blog post and make my decisions as to whether I should be going with the AIC or the RMSE, but I think I'm going to be going with the RMSE. So since I've gone through this code review and I've explained what my experimentation was, and I said what I think I'm going to do, I'm going to go ahead and conclude this video. But what I would like to do is I would like to thank all of my subscribers for subscribing to my channel. If you like this video, please like, subscribe, and share. And thank you so much for watching my video.